Hi mathematics grade 12s. Here today we are going to be looking at the quadratic function, which is the parabola function. It's one and the same thing. You can call it quadratic function or parabola functions. We know that there is two kinds of equations in the quadratic function. That we've got a standard form and the vertex form in the quadratic. Alright, let's write down the standard form. The standard form will be y equals to ax squared plus bx plus c. Right, this is our standard form. And then our vertex form will be y equals to a, open the bracket, x plus h all squared, then plus k, right? Where h will be the value of x in the vertex point and k will be the value of y in the vertex point. That was the two equations of solving the quadratic function or parabola functions problems. All right, let's get to, we are going to just look at the just two examples. One example in a standard form and another example in a vertex form, where we are going to be looking at how we can plot the graph in a standard form or in a vertex form, and we will be looking at some important things like a vertex point, axis of symmetry. We'll be also looking at the domains and the range, how we analyze the graph to find the domains, how we analyze the graph to solve some problems, whereby you will be getting some questions asking for what values of x is f at x or g at x, or the y or y equals to or y greater or lesser than 0. We'll be dealing about all those things. We'll be looking at just the basics in terms of the quadratic functions. We want just to start with the standard form. Let's write the formula. Let's write the equation formula for the standard form again, so that you don't forget it. It will be on your screen as we deal with those examples. Our standard form, we said it is y equals to ax squared plus bx plus c. Y equals to x squared. Y equals to x squared plus 2x minus 3. All right. Here we want to plot a graph, but before we are able to plot the graph, we have to go through some steps, of which we are going to start by looking for the vertex point. To find the vertex point, there is this formula which says x equals to negative b over 2a. That's your default formula to get the x value of the vertex point. What is our b here? Our b, we know that b is here, the position of b is here, which means in this equation the value of b is 2. So we are going to say negative 2 here, over 2 is provided in the formula already. Then we open the bracket. We want the value of a now. The value of a is here, so which means it's 1 here in this case. Negative 2 over 2 times 1 is 2. Our value of x in the vertex point will be negative 1. That's the value of x in the vertex point. We will be substituting this value of x here in this equation now. Right, let's do that. Y equals to x squared. We rewrite the formula so that you follow it very, very nicely. Or here it's 2, it will be 2x. My writing will be terrible because of the app I'm using. Minus 3. We've got y equals to, now we are substituting this negative 1 for x value here in this formula, of which is, it will be negative 1 all squared plus positive 2, but we open the bracket and say negative 1 inside the bracket, then negative 3. This is a terrible writing, but you will forgive me because of the app. My handwriting is very, very nice, but here, because of this app, it will be terrible sometimes. Our y will be equals to, then it will be 1 minus 2 minus 3. It's 2 times negative 1, which is negative 2, and then this negative 3 goes down like this, and then our y value in the vertex point will be, let's just say, negative 2 and negative 3 will be negative 5. Negative 5 minus 1 will be negative 4, because we take the sign, the sign of the bigger number. It's our y value in the vertex point. I'll change the color when I'm writing the vertex point so that it is clear to you. Now our vertex point will be negative 1 is to negative 4. That's our vertex point with another color. Now that we have our vertex point, then we can be looking for x-intercept, y-intercept. Our equation, you remember that our equation was y equals to x squared plus 2x minus 3. And then we remember that our vertex point was looking for the x and y-intercept. Let's start with the y-intercept. For y-intercept, let x be equals to what? You know now, x must be equals to 0, which is very, very terrible 0. It's like, I don't know. Okay, but now let's continue. Y is equals to, open the bracket, we've got 0 all squared plus 2 into 0 minus 3. Our y will be equals to negative 3. Why? It's because 0 plus 0 is just 0. So we've got y equals to negative 3. That's our y-intercept. And then looking for x-intercept. For x-intercept, let y, if you will, let y be equals to, you know now. So now 0 will be equals to, according to the equation, it will be equals to x squared plus 2x minus 3. We can just open the bracket here. Then we've got x here. You know now how to factorize. Our values will be x plus 3 and x minus 1. And then which means we've got x equals to negative 3 or x equals to positive 1. Those are the x-intercept and y-intercept. Got negative 3 as our y-intercept, negative 3 as x-intercept, and also positive 1 as the x-intercept. Now we can be able to draw our graph. Our y-intercept is equals to what? Negative 3, if I remember quite clearly. X-intercepts are x equals to negative 3 also, and also x equals to positive 1. And then our vertex point, let's change the color for vertex point, negative 1 comma negative 4. You still remember quite clearly. Right, plot it roughly. Negative 4, we've got 1 here, then we've got negative 1, negative 3. Right, why do we have these points here? We've got a negative 4 for vertex point and negative 1. Our vertex point here, this is like this. This is the axis of symmetry. If you're looking for the axis of symmetry, this vertical line where there is the value of x in the vertex point, it's where you can identify the axis of symmetry. Negative 4 in y values and negative 1 in the x values, like here. Now that we've got the vertex point here, our graph will look like this now. It will pass negative 3, and then here, this is our turning point. It will just go like this. X-intercept here. This is our x-intercept is positive 1, and our x-intercept, which is negative 3. Okay, this is how our graph will look like. The vertex point helped us to find the turning point, and also the x-intercept as well as the y-intercept helped us to see where the graph will pass in through the y-intercept and the x-intercept. Oh, sorry, we had to include this y-intercept here, which is negative 3 here in this point. But there is another way to plot this graph. I don't want to give you only one method. There is another method of which we are going to be looking at. On this method, we won't be using the y-intercept and x-intercept, but we are going to be finding the vertex point, and then we are going to use the table to find another points where the graph is going to pass through. And then another thing you have to know is that when the graph is smiling like this, it means that the graph is positive. It is always positive. But when the graph is set like this, it means that the graph will be always negative. The fact that the graph is smiling like this in this equation, in this function, it means that it is positive. But if it was like this, it will be a negative graph, right? Okay, let's continue this other method. It's the same problem, but we are changing the method. We are now not going to use the x-intercept and y-intercept. Let's go for it now. Our equation was like this. It was y equals to x squared. I still remember the equation, plus 2x minus 3. That was our equation. Let's just find the vertex point. You know now that our vertex point will be x equals to minus b over 2a. Negative b is 2. Then open the bracket. We've got 1 there in the place of a. Then our x will be negative 1. We already know that. Then to find the y vertex point, we substitute that one, negative 1 all squared plus 2, open the bracket, negative 1, then minus 3, negative 1 and negative 4 for y values. Our table will be x here and y here. That's our table here. We are going to use this vertex point, but we always start here in the middle and say we've got minus 1 and minus 4 for y values in this vertex point. All right, this is negative 1 and negative 4. 2 points on top, 2 points downwards. From this x value going upward, you are going to decrease the values. So which means here we've got negative 2. Always you decrease the values on top, negative 2 and negative 3. For x values, we are going to find the values using our input values, which are x values. The y values are output values. And here, after negative 1, we've got 0 and we've got 1. Then we are going to use the input values to find the output values. For y values, we are going to substitute like we did for negative 1. We substituted negative 1 to find negative 4. We are going to do the same with say 0. Substitute 0 in the formula. Now we are going to say y equals to, now we are substituting 0 all squared plus 2 into 0 minus 3. You can see that 0 squared plus 2 times 0 plus 0 is just negative 3. So which means our y value here will be negative 3. Then we go back to the table where there is 0. We put what? Negative 3. We are going to be substituting 1 in a formula. Same formula, y will be equals to, now we are substituting 1 all squared, 1 squared plus 2 into 1 minus what? 3. Then in this case, y will be equals to, then 1 all squared is 1. 2 times 1 is 2. So we've got 1 plus 2, which is 3, minus 3, y equals to what? 0. So which means here, where there is 1, we put 0. You need to know that always, once you find the value from here, when you reach here, once you find the value of 0 to be negative 3, it means that here also will be negative 3. If it is 0 here, also here it will be 0. You can take this value and substitute it back into the formula. It will give you negative 3. We don't have that time, but you can do it yourself. Also here, you can take this value and substitute it in a formula. You'll get 0 like here. Yours is to just find the value of here. When you find it, then you put it here. This thing goes with this one. This one goes with what? With this one. So you just memorize it like that. Now that we've got those points, let's just put it here so that we are able to plot the graph here. Let me just plot it just in this line. line. Another line here. We've got -4 here. This is our 1, -1. And we've got our -2, -3. We've got our -3. All right, those are the points of which we need for this graph. Where there is -1, there is -4. That's our point here. Where there is 0, there is -3. Where x is 0, our y will be 3. Okay, our y is 3, where our x is 0. Where x is 1, our y will be 0. Where x is 1, our y will be what? Will be 0. Where our x is -2, our y will be -3. Okay, where x is -2, our y is -3. Okay, x is equals to -3, our y will be 0, which is our x-intercept here. This is how our graph will go. Our graph will go like this. This is our turning point, then back to here. This is our graph. Look at this graph. It's the same graph. Look at here and look at here. Same graph, it's the same graph. It passes at -3 and 1, and the vertex point is here, and also here it passes at -3 and 1, and our vertex point is as -4. Right, I think we are clear with this one. Now we move to another equation, which is the vertex point equation. It's y equals to a into x plus h all squared, then plus k. Y equals to, say we've got x minus 1, x minus 1 minus 2. Your vertex point will be very, very easy. What you're gonna do is, for vertex point, you just say v will be equals to 1 is to -2. That's our vertex point. I'll tell you why. Always when there's x minus something, you just change the sign to put the x value. Always change the sign here. If it was x plus 1, you will have a -1 for vertex for x values of the vertex point, and then the y value, just put it like that. If it's +2, you will say +2. If it's -2, it's -2. That's how you find the vertex point. It's not like in the standard form, whereby when you're looking for vertex point, you start by saying x equals to -b over 2a, and you find that x value, and you substitute it from the equation to find the y value of the vertex point. Here it's not like that. Here you just look at the equation and say, or if it's -1, then it will be +1. Going to the table, how to go to the table now, the input values and our output values, which are y values. All right, I said you just put 1 here, y value here, which is -2. Which values are less than 1? We've got 0 here and -1 here, and here we've got 2 and 3. Right, let's just substitute 2 and find the value of 2, and substitute 3 to find the value of y. Right, our equation will be y equals to, when we substitute 2 minus 1 all squared minus 2. Well, our y will be equals to, when you look at here, 2 minus 1 is 1, then 1 all squared will be 1. Let's just put it for your benefit, will be 1 minus 2. So we all know that 1 minus 2 is just -1. So which means here we've got -1 as y values, or as the output value. We can also substitute, now we substitute 3 to find the output value. When you substitute 3, it will be, open the bracket, now we've got 3 in the place of x, -1 all squared minus 2. Then our y value here, 3 minus 1 is 2 squared. 2 squared is 4. Right, so which means our y value here will be equals to is 2. Then we've got 2 here. Right, I told you lastly that this goes with this one, and this one goes with this one. So what does that tells us? It tells us that we've got -1 here and we've got 2 here. I think it's clear then we can be able to plot the graph here. Our graph will look like this. The values we need here, we will need -2 here, -1, and we will also need -1 here, and we will need 1 here, we will need 2 here, and also 3, and then we will need maybe 2 here. Where there is 1, we've got -2, we've got -2. That's our vertex point here. That's our turning point actually. Then where there is 2, there is -1 in the y value, in the y values. Where there is 2, there is -1. This is another point that we have. Then where there is 3 in the x values, we've got 2 on the y values. 3, where there is 3, we've got 2. On the other side, where there is 0 on the x-axis, we've got y, we've got 1. Sorry, we've got -y, which is our y-intercept. And then where there is -1, we've got 2, so which means where there is -1, we've got what? 2. We've got 2. So our graph will just go like this, pass through here, then this is our turning point, then it will just go like this. And okay, you just plotted the graph, but our problem with this method is that we don't know where it passes here, because 2 is here and 3 is here, and here it can be 2 comma something, but we don't know the actual value. So to know the actual value of this point here, we need to go to another method of plotting this graph, which includes what? Finding the x-intercept and y-intercept just after the vertex point. So what we are going to do, we are going to do another method now. We know our vertex point. What is our vertex point? Our vertex point is 1 is to -2. Let's say y is to 1 is to -2. That's our vertex point, if you will. Y1 is -2. Right, we don't use this method of table now. Now we are going to look for x-intercept and y-intercept, right? That was our equation. Now to find y-intercept, if you will, let's start with the y-intercept, if you will. For y-intercept, let x, you know now what will be x. X will be equals to 0. Right, now that we've got this equation, then we will manipulate the equation and say where there is x, we put 0, -1 all squared minus 2. What will be our y-intercept? Our y-intercept will just be 0 minus 1, it's just -1 all squared, 1 minus 2. Just forgive my writing. Our y will be equals to -1. Right, this is our y-intercept. When we look for x-intercept, now let y equals to 0. 0 equals to, open the bracket, x minus 1 all squared minus 2. Right, to find the value of x, you can transpose -2 to the other side of equal sign. It will become +2. Open the bracket, x minus 1 all squared, square root here, square root on both sides, plus or minus 1 comma 4 here. The square root of 2 is plus or minus 4. All right, here it will remain as x minus 1. X minus 1 will be equals 1 comma 4, or we can also say that x minus 1 will be equals to negative now 1 comma 4. Right, but one can ask, why we're doing this? It means that x minus 1 is equals to either +1 comma 4 or -1 comma 4. So that is why we've got this sort of thing. Now we can be able to plot the graph. Yeah, what are the points that we need? -2 and 1 here, 2 here, and 3 here. Then we can put 1 here, which is -1 for x values. We can put 2 here for y values. Right, we can put -1 here. All right, the points that we have, we've got our vertex point is also -2. Is 1 is to -2. Our y-intercept is -1. Okay, x here will be equals to 2, 4 here, or x is equals to -0, 4. So that's our answer for the x-intercept and y-intercept. So which means here our x-intercept here will be 0, 4. All right, and then our x-intercept here also is 2, 4. We can put it somewhere here. We are able to plot our graph. Our graph will go like this. Let's analyze it a little bit. Okay, here this is the vertex point. We now show that here it's 2, 4, this point, and this point is 0, 4. But for the other graph, we were not sure of what was the points here. You look at here, we knew the vertex point, but we didn't know what was the point here, what was the point also here. But now, thanks to the y-intercept and x-intercept, we now know that the point here is 2, 4, where the graph passes here, and the point here is 0, 4 also. I think it's clear here. Now, what I'm going to do now, using these graphs, I'm going to show you how we identify the range and the domains. We've got this one. We've got this thing now. For us to find the domain, -infinity to infinity, and the brackets will all be small brackets. Why? It's because it's from infinity to infinity. So domain is just x values. All right, x values. Because this one is a positive graph, it has got a minimum value of y, which is the minimum value of y is the vertex point is the positive graph of the quadratic function. The positive one has got a minimum value, which means there is where the y values start at the bottom. They start at -2 up to what? Up to infinity. We don't know where they end. The y values, we don't know where they end up here. So now we now say, okay, for the range or for the y values, they start from -2 up to what? Up to infinity. We don't know where the y value ends. It just starts here. But here, because we don't know where it ends, small bracket, right? That is how we identify the domains and the range. And once again here, it's for y values here, right? Okay, so you can actually see that for y values, the y value will start here. It does not go downwards to the smallest values. It's just that from -2. But where does it end? We don't know where will it end as it goes up here, right? But for the x values, it starts from infinity to infinity. If we can try to draw something here, it goes up to infinity. We don't know. Maybe we can have -1 here, maybe 10 here, -1 million. I don't know where it will end. It will just continue to go that way. We don't know where it will end. And also that side, it will continue to go, I don't know, 1 million or something. This side, the x values are from -infinity to what? To positive infinity. So always like that when you're looking for the domains, right? That was just a rough illustration to give you a clue of what we are talking about. Now we go to another thing. Now they will just ask you, maybe they will say y, or say this, maybe this one is f at x. Maybe they said it's f at x. For what values of x will f at x maybe be greater than 0, or maybe f at x less than what? 0. So they will ask you a question like this, that for what values is f at x? F at x is y, whereby y is greater than 0, or where y is greater than 0. Okay, when you look at this this formula for greater, we use green. and we will use yellow for less than. Okay, now you can actually see that from here up to negative 0,4 here, and from here to infinity, from infinity to negative 0,4 here, we see that the y values will increase from 2,4 up to infinity. Again, the y values will be increasing. Y values will be increasing. So when they ask you for what values of x is y going to be, okay, this is the answer here. F at x greater than 0 from negative infinity to negative 0,4. Then you put u here, which means it's united here, from 2,4 up to positive infinity, Yeah, when they ask you this question, for what values of x is f at x or y is greater than 0, it's from this from infinity to 0,4, and also from 2,4 up to infinity. It's where we find that the y values are continuously increasing. Now we come back to where now we were asked for, whereby f at x is now less than 0 now, and the answer will be now, you can see just from between 0,4 to 2,4. This is the whole portion whereby from negative 0,4 up to 2,4. That's the only portion whereby y is going to decrease. Is decreasing, negative 1, negative 2 up to infinity. The y is decreasing. So it's whereby, so the answer here is negative 0,4 up to 2,4. So that's the answer for this one now.